Welcome to this lecture series in coordinate geometry. In this lecture, we'll look at a certain other form of the equation of a line. I initially intended not to cover it, but I then found an interesting example where it kind of shows up. It is again just common sense, but I have to dedicate a separate lecture to it. So all one needs to know is what is meant by slope of a line, meaning of the equation of a line, what is a line, just very basic concepts about the coordinate plane. All right. So it is called the polar form, as it were. So we have this coordinate plane, we have a line passing through the point h, k, and it makes an angle of theta with the positive direction of the x-axis. Suppose we have a point x, y at a distance r from this point, but again, this distance is kind of signed distance. So as you go up, it is positive. As you go down, it is negative. So if you go up by distance r, then x is this thing, h plus r cos theta, simply because this much is h, and as you drop these perpendiculars in this triangle, what is this thing? This is r cos theta, because this is theta, this is r, so this is r cos theta, and you add that to h, and you get x is equal to h plus r cos theta. So I was a little bit hasty, but I'm sure you get what this is if you know your basic trigonometry. Similarly, y is equal to k plus r sin theta. All right. And if you were going down, then it would come with a minus sign. So instead of r, you would be doing minus r. That's all. Okay, so this is called the polar form. Again, there is no need to remember such things. Let us just look at a nice application. So we have a line through this point, minus 5, minus 4, as shown in the figure. So there is this mysterious line which we will need to figure out what this line is, this orange line. This line meets these three given lines. So these three given lines have been drawn here. So these three given lines is met at point B, C, and D as shown, B, C, and D, such that this funny equation is satisfied. So this means the distance between A and B, this means the distance between A and C, and so on. So this is satisfied. We need to find the equation of the line, this orange line. Now, if you start with the, let's say ax plus by plus c form, so you assume that your line is ax plus by plus c equals 0, then you can solve for the point B, point C, and point D. You have three unknowns, A, B, and C, and, well, not really three unknowns, because you already know that the line passes through the point minus 5, minus 4. But anyway, you have start with some A, B, C, and then you find the coordinates for the point B by solving for this line and that line, and similarly solve for coordinates C and coordinates D, and then you substitute them here, and then you'll get another horrible equation. It will be unmanageable. So that's certainly not a good idea. But if you go with the polar form, things become very, very easy. All one needs to do is find the slope of the line, because we already know a point through which it passes, and that is how we will go about it. Okay, so let's say the distance between A and B is r, the distance between A and C is s, and the distance between A and D is t. Okay, we are given that this holds. Just distance between A and B is r, then s, then t. This is given. Now let me start from scratch. So what is the equation, or what is the expression for the point B now? So let's say this angle is theta, the angle that it makes with the positive direction of the x-axis. The angle that the line makes with the positive direction of the x-axis is theta. So what is the point B? The coordinates of the point B then become minus 5 plus r cos theta, minus 4 plus r sin theta, right? For the point C, we have minus 5 plus s cos theta, comma minus 4 plus s sin theta. And for the point G, we have minus 5 minus t cos theta, minus 4 minus t sin theta. Because we are going down here. This is coming down. Now, it doesn't really matter for this particular problem whether you use plus t or minus t, simply because there are squares involved. So even that mistakes get automatically corrected. But it is a mistake to write plus t if you are using t as a positive number. If you're using t as a negative number, then it's okay. But we defined t as the distance between a and t. So it is a positive number, and hence we must account for it by putting a negative sign here. Okay. So now we just use the fact that B lies on this line, C lies on that line, and D lies on this line. So when we do that, what do we get? I mean, this is the part where I have to work a little bit. So x plus 3y plus 2 equals 0. So B lies on this line, this one. So we will just substitute these 2 points in place of x and y. I mean, these 2 numbers in place of x and y. So minus 5 plus r cos theta, this is x, plus 3 times minus 4 plus r sin theta, plus 2 equals 0. We have that because B lies on that line. Let's solve this. Let us kind of solve for r. Let's see what happens. So this implies minus 5 plus r cos theta, minus 12 plus 3r sin theta, plus 2 equals 0. Okay. So we get minus 17 plus r, or not minus 17, it's minus 15 plus r cos theta plus 3 sin theta equals 0. So we will get what is r in terms of theta. So r is 15 by cos theta plus 3 sin theta. Yep. So let me bracket it out, or rather box it out. We have this. Similarly, if you let me do it. So for the now we do for the point C. So point C lies on this line. So if we play the same game, we get minus 5, or rather twice of minus 5 plus s cos theta plus minus 4 plus s sin theta. Just substituting the values of x and y, plus 4 equals 0. Again, let's solve this. Okay, so that's what we get for s. And now finally we need to do the same thing for t. And I'm a little bit scared because I have to use another page. So let's do it. There is no option. So the line that we have to satisfy is x minus y minus 5 equals 0, and the point that it has is this one. So x is minus 5 minus t cos theta. Such a bad handwriting. That's x. Minus y is minus 4 minus t sin theta, and minus 5. That's the equation, and if we solve it, what we will get? Okay, this is what we get. So now we will just use the expressions for r, s, and t that we get. R, S, and T. So we just have to substitute, and the numbers match very nicely: 15, 10, and 6. 15, 10, and 6. So basically what we will get is, if you substitute the values, you will get, and this is a minus t, so let's write a plus t, although it doesn't really matter because squares are involved. There's a minus here. Okay, so what we have is, by the given thing, we have cos theta plus, cos theta plus 3 sin theta whole square plus 2 cos theta plus sin theta whole square equals cos theta minus sin theta whole square. So how did we get this? When you substitute r equals that here, you get, because this is in the denominator, you just shuffle things around, you get the square of this, similarly for the other things. So that's how you get this equation. And now this is just a battle with trigonometry. So this is cos square theta plus etc. etc. So now what do we do? So if you solve it, you will get 4 cos square theta, because one guy cancels out, plus 9 sin square theta plus 6 plus 4, 10 plus 2, 12 cos theta sin theta. This is equal to 0, and fortunately this is 2 cos theta plus 3 sin theta whole square. Otherwise it would be a quadratic. So this means 2 cos theta plus 3 sin theta is 0, which implies tan theta is minus 2 by 3. So that is the slope of the line. And now you know a point through which this orange line passes, meaning namely this point, and you already know the slope of this line. So you can just write down the equation of the line. What you will get is, I think I have pre-computed this, you will get 2x plus 3y plus 22. This is the equation of the line, orange line, written in orange. Alright, so that's an illustration of how to use the polar form. With that, I want to end this lecture. As usual, like, comment, share, subscribe, and I will see you next time.